Hi everyone, it's Mrs. Burke. I'm home still. Anyway, I decided to make a video for you all about just a recap on what we did on Monday. Because before I come back and move on to the next thing, I want to make sure that we remember what we did on Monday of this week, which was on one sample t-test. So before I go on, let's go over our homework that was assigned on Monday, and that was called Homework 5. All right. So if you could take out Homework 5 right now, that would be great. Okay. So we're looking here at Homework 5, and we see that we were given a set of data. So notice this data here. We're going to enter it in L1. So you should have gone to your calculator and gone to Stat, Edit, go to L1, and you should have entered all the data here, and then go to Stat, go over to Calculate, and go to number 1 var stat, and make sure it says L1, make sure there's nothing in L2 in frequency list, and then hit Calculate. And when you hit Enter, you should get your mean X bar and your standard deviation S, and that's the standard deviation of the sample, SX. So when you go over here to my work, you see I'm going to circle the mean here, 108.3, that's my sample mean, and the standard deviation S, okay? That's what I'm going to use for this example. So this question was about IQ, and it said that the distribution, the overall distribution by IQ scores was normally distributed, so that's important, approximately normal. And it said that the mean was 100. Now this to me sounds like the mean of the population, so I would label that mu for the population parameter 100. Notice we have the word mean here, so this is a mean question, so I do want to write that down as well. Okay, now it says that it was hypothesized that AP teachers have a higher mean IQ. Ooh, man, they're smart to think that the AP teachers are having a higher mean IQ. Oh, I hope so. So here we have a sample of 10, so that's your sample size N. And right away you notice that I only have 10, so that's a small sample. So I'm going to have to plot the data because I'm not going to be able to use the central limit theorem. And I also now know I have the sample mean X bar, which I got over here, and that was the 108.3. And I have the sample standard deviation S, and that was 9.499. Okay, so I'm going to use this information now to proceed with my question. So it says, do these data provide convincing evidence? Evidence is going to be your p-value at the 0.05 significance level, so that's your alpha level, that AP teachers indeed have a higher mean score. So higher score, so that's going to be your direction of your alternative hypothesis. It's going to be a greater than sign. Okay, so we're going to do the full phantoms procedure. All right, so let's start with our P step. Step 1, state the population of interest and the parameter of interest. So the population of interest, remember, this is the part where you guys are having a little trouble. It's taken from, the sample is taken from the population. So it said a random sample of 10 AP teachers. So that would be taken from all AP teachers because it said it was a sample of AP teachers. So the population is all AP teachers. It's not all teachers. It's a sample of AP teachers, so the population is all AP teachers. And then the parameter is mu, and it's stated above somewhere. It says the mean IQ score. So we just take it right out of the question, the mean IQ score of the AP teachers. Because remember, we're trying to make a statement here about the IQ of the AP teachers and if it is indeed greater than the all teachers, okay? Regular teachers, non-AP, I should say. All right, so now we're going to do our H step. That's the hypothesis step. So H, this is P. All right, so your HO should have been mu equals whatever the mean was of all teachers. Oh, it said that the distribution of IQ scores for all adults was 100. So that is the general IQ of the general population. And then the alternative is the mean is greater than 100 because we're assuming that the mean IQ score of the AP teacher should be higher than the general population. So that's our goal. All right, so we have our null, we have our alternative, and now we are ready to proceed. And again, we could write this in words, but for the sake of time, I won't. Okay, so assumptions. Is it stated to be a simple random sample? Let's look back to the question. It said it was a random sample, okay? So it didn't say a simple random sample, but it did say a random sample. Random sample stated. Sorry about this handwriting here. This is on my home Surface, and it's ugly. Yikes. Okay, next thing we have to check is 10 times n less than the population of interest, meaning is the sample size 10% of the population. So the sample was small, right? The sample was size 10. So is 10 times 10, which is 100, less than the population of all AP teachers? And that's definitely true. Okay, this is getting really ugly. Woo. And then the third one is, remember, normality. So remember, if it was a proportion question, we'd do NP times an NQ and see if they're at least 10. But for this, we either use the central limit theorem, but that's not met. They did say the overall population is approximately normal. And then when we did our plot here of our box plot, which is over here, you see that it is approximately symmetric with no outliers or extreme skewness. Now let's remind ourselves how to get there. So I press second y equals, I hit enter on plot 1, I hit enter on the word on. I went down and to the right, I chose my box plot or your modified box plot. Here's a modified box plot. And then zoom 9, which is zoom stat. And again, there's no outliers here, so that's pretty good. So I'm just going to refer to the box plot. Box plot shows no, wow, this is coming out really bad. I'm sorry. Outliers or skew. So I can proceed. Oh man. All right, so now we're going to proceed with our step N. All right, the name. Let's see if I could go to typing. That might be easier. Name. Not easier when it shows up over here. Yikes. The name is called a one sample t-test. And you could say for means, but you don't have to. Okay. That's it. We're done with the N. All right, let's move on. Oh, where did it go? This is why I don't use the clicky board, because as you can see, it is frozen now. That's great. All right, let's move on. So the next part is the part that everyone's been asking me about, and they've been telling me that they've been kind of confused, and that is the T-step. So the T-step is to actually do the test statistic. All right, so the test statistic is the formula on the reference sheet. Statistic minus parameter over standard deviation or standard error of the statistic, okay? So in this case, this is going to be a t-score. It's going to be a t-score because we don't know the standard deviation of the population, sigma. So we're going to do x bar minus mu sub x bar, which we're assuming is whatever's in the null hypothesis, over the standard deviation of x bar, which is going to be called the standard error of the mean. Okay, so remember that formula is going to be S divided by square root of n. All right, so let's substitute in our numbers here now from our X bar, we have 108.3, and then our mu, which we're assuming in the null, is 100. All right, so let's plug that in. 108.3 minus 100. And I forgot we should really be sketching this. So the sketch we'll put over here, mu sub 0, that's what you're assuming in your null, that the mean is 100 of the AP teachers. But then the X bar that we obtained from our sample was 108.3. And then we would go to the right because our alternative direction was to the right. So the p-value we would be interested in finding would be to the right. All right. So we have to still put in our S, which is our sample standard deviation. And we got, I see, is it still up here? No, of course not. All right. It is 9.499. So we're going to have 9.499 over radical 10 in the denominator. And the numerator is staying the same, 108.3 minus 100. Okay. All right, this is pretty ugly. So now at this point on the AP, they will allow you to go to the calculator for your answers. So you don't necessarily have to actually calculate this t-score by hand. So what you can do is go to stat, go over to tests, and you're going to go down to number 2, t-test. And you're going to either choose data or stats. I have data in my list, so I'm going to choose data because it's still in there. And then I would put in my mu sub 0, which is my null hypothesis of 100. I would choose L1, and I would make sure that the frequency is only 1. I would make sure that my alternative direction is a greater than sign, okay? And then I'm going to either hit calculate or draw. So let me drag this over so that it's saved. Okay, so that's what I entered. And now I'm going to hit calculate or draw. I'll just choose draw. All right, so it's going to draw the bell curve. It's a t-score, remember, not a z-score. So it's not exactly a normally distributed curve because it's going to be wider and fatter and more variable. And then you see the t-score is 2.763 and the p-value is 0.011. So 2.763, 0.011. 2.763, that's the test statistic. And then the p-value that we got was 0.011. So if you obtain the p-value, you get a p-value of 0.011. Okay, so our last step is going to be to make a decision and either reject or fail to reject the null hypothesis. So notice we go back to our alpha level, and I just went back and scrolled, and it was the 0.05 level. So is 0.011 less than alpha equals 0.05? You should say yes, because 0.01 is less than 0.05. I will reject the null hypothesis, and thus I can conclude in favor of the alternative hypothesis. So let me see if I could type this without screwing up here. Let's see. All right. Let's try it. Because my p-value of 0.011 is less than alpha equals 0.05, I reject the null hypothesis. So that's my decision. And then I say, thus, I can conclude, indeed, that the true mean IQ level of AP teachers is higher than the general population. Nice. That's good news, right? Okay, so how did you do last night? That's my first question. Did you reject the null? Did you get the right p-value? Did you remember to put your data in stat edit? Did you remember to plot the data? Did you remember to refer to the plot? Did you understand how to put in your test statistic? Again, I think the biggest thing that I'm noticing that kids are having trouble with is this step over here, the t-score. So maybe let me pull this to the side here and uncover it so you can see it a little better. All right, so the formula for the t-score again is statistic, which in this case was x bar, minus parameter, which is mu, that you're assuming is true in the null, and then over standard deviation of the statistic. So standard deviation of the mean, the formula is sigma over radical n, but I don't know sigma, so I put s in its place, okay? So that's the homework. Okay, now we're going to go to our classwork, which it should be in your notes folder. So take a minute and look in your notes folder, and you're going to look for day, I want to say day 9 notes. And it's going to be 2 practice questions. So we're going to see how far I get and how long I take to go through this first one. Okay, here we go. Day 9. Okay, so please find it. Pause the video if you need to. Day 9 notes. A classic rock radio station claims to play an average of 50 minutes of music per hour. Okay, so let's circle that or highlight that, okay? Let me get my highlighter maybe. Great. So this is what they're claiming. Average, okay? So right away, I know that that's a mean question because it says the word average. And the claim is mu equals 50. And that's probably going to be the null hypothesis, okay? To investigate the station's claim, you randomly select 12 different hours during the next week. All right, so it sounds like that's going to be the sample size, 12. And it was randomly selected. And record what the radio station plays in each of the 12 hours. Here is how much music was played. So here's your sample. So right now, I want you to stop the video and go to Stat Edit. Okay, go to L1 and enter the data in L1 for me. Okay, and then after you do that, I'm going to go to Stat, go back to Calc, and I'm going to choose number 1, 1 bar stat. Make sure it says L1. And then you're going to find me your mean, X bar, and find me your S. Okay, so take a minute and do that. Okay, I'm going to do it as well. You might want to pause the video while you enter the data, okay? So do that now. Don't just watch me. And then we hit calculate. All right. So I have 48.917. 48.917. I better write that down. 48.917. That's the S, the mean. And the S is 1.929. 1.929. Okay. All right, and then also I know I do have to plot this data because it's a sample of size 12, which is too small. So I will do that now. I'm going to press second y equals. Hit enter on plot 1, enter on the word on. I'm choosing the modified box plot, zoom 9. And it looks pretty good, okay? So I would probably want to draw this. It looks a little slightly skewed to the right, by the way, longer whisker on the right, but not by much. It's not the best graph. All right, good enough for now. All right, state the appropriate pair of hypotheses. Be sure to define the parameter of interest. All right, so they're asking me to jump to the H step, which is the hypothesis step, okay? So let's scroll down. There we go. So our HO is going to be always an equal sign. And remember, it's always mu for both of these because it's a mean question. And they claim that the average is 50 minutes of music per hour. So we're going to put 50. And then remember, it said define the parameter. So the parameter in this case is the mu. And that's going to be the mean or average number of minutes of, what are we measuring? A music played every hour. What just happened? Music played per hour by the radio station. All right, so hopefully you said that somewhere. The population is, I think, the hours of the radio station, because we said they chose a random selection of hours played of music from the radio station. All right, so the alternative. So what are we claiming to be true? It says that they're claiming it's 50, and then we got 12. All right, and so it looks to me like they don't really give you a direction in this case of the alternative. It seems like they're just saying that they're claiming it's 50, but you want to just investigate this. So it doesn't seem like they gave you a direction. So what we're going to do is do a two-sided tail, which means it just differs from 50. All right. So the null is that it is what they're claiming it is, which is 50 minutes of music per hour. And the alternative is that it just differs from 50. Okay. Two-sided tail. And again, that's just because they didn't really give me any indication of which direction to go in. All right, so now we're going to check our conditions. So condition 1, assumptions. Is it an SRS? It stated that it was random selection of hours from the radio station. That's good. 10N. What was the sample size? 12. Okay. Hopefully that's less than the population of all hours of music played by the radio station. So that's check. And then lastly, the sample size was too small to use a central limit theorem. So I can say by the box plot, there are no there's no skewness, no extreme skewness or outliers. So I could proceed with a T procedure. T procedures are called robust, which means they kind of like, they still hold up even if there's an assumption that has been violated. All right, so we're done with the P step, we're done with the H step, we're done with the A step. But now this is a little different because it doesn't just ask you to find the test statistic, which we can do, and maybe I'll do that at the end. I want to go to part C real quick and see what it says here. It says a 95% confidence interval for the mean was performed, and we ended up getting this interval here. So let me highlight this interval. Okay, right here. Based on the interval, what conclusion would you make for a test of hypotheses in part A? So what this is saying is, even if you had not actually gone forward and done the entire phantoms, which is the test statistic and doing the test, finding the p-value and all of that, if they just gave you an interval, which they did, and they said, here's the interval we made, what would be your conclusion? So remember, we've kind of tied our intervals into like talking about, is something typical, is something likely, or is something unlikely? So do you see the interval that they gave us here is numbers from 47-ish to 50.1. Now, if you look at your null hypothesis, do you see that the null hypothesis is the number 50? So do you see that 50 does lie in this interval? Since 50 lies in this interval, that means that 50 is a plausible value because 50 could fall in that interval. So if it's plausible, are we going to reject it? And the answer is no. If the null hypothesis is a plausible value and it is contained in the interval, we do not reject it. And that's called fail to reject, okay? So I did not even get a p-value yet, but I'm telling you that because the null hypothesis value of mu equals 50 is contained in this interval, it is plausible. Well, I shouldn't have made a capital there. It is a plausible value of mu. Thus, we fail to reject its value, which is the null hypothesis. And we can conclude in favor of the alternative, which says the mean number of minutes of music played by the radio station. Whoa. Uh-oh, I'm having an issue. Thus, we fail to reject the null hypothesis, and we cannot conclude that the mean number of minutes played by the station differs from 50 minutes per hour. Sorry, I know this looks like a different language right now. I apologize, I don't know what's up with this internet, but basically the concept is this. If the null hypothesis is contained in the interval, you can't reject it. If the null hypothesis is not contained in the interval, then you do reject it because it's not plausible. So now I'm going to go forward and actually find the p-value with you on the calculator, and we're going to see if we would have rejected the null or not, okay? So let me scroll back up to my data. My data is still in L1, remember. So if I had gone to stat and gone over to tests, and I chose my t-test, which is number 2, and I choose data because I have data in the list, and I put in the null hypothesis, which was 50 minutes per hour. I choose L1, and then I choose the not equal to sign for the two-sided alternative. And then if I choose calculate and enter on this, look at the p-value. Do you see that the p-value here is 0.077, 0.078? And that number is not less than 0.05, okay? So I would not have rejected the null hypothesis, and thus I could not rule in favor of the alternative. So this p-value concludes what I said. It kind of affirms, actually confirms what I said about not rejecting the null hypothesis. So I will write this down. The p-value is 0.078. The p-value is 0.078. And that kind of confirms what I just said. So again, because that's not less than 0.05, and that's greater than alpha equals 0.05, it means fail to reject the null, which is what I said above here, fail to reject the null. Okay, so another way of doing things without fully doing the whole phantoms and the p-value is if you look at the confidence interval, and this was a 95% confidence interval, and if the interval, I think, was between 49 and 51, contains the HO value, which was mu equals 50, then you can't reject it because it's contained in the middle. But if the null hypothesis value falls in the tail, let's say our HO was mu equals 60 instead of 50, then it will lie in this tail, and this tail is tiny. Why is this tail tiny? Because remember, if the middle chunk is 100%, 95%, 100 minus 95 is 5, and 5 divided by 2 is 2.5. That means that this little probability is less than 5% likely if it lands in the tail. So if it lands in the middle, in the interval, it's likely. If it lands in the tail, it's unlikely. Does that make sense? I hope so. Okay. So now, lastly, we go back to part D. And part D says, can we generalize our conclusion for this radio station for the whole year? I don't know. Let's see. It says that we took a random select 12 different hours during the next week and record the results. Can we generalize it to the whole year? I don't know. I would say because the hours were only selected from this week, I would be like nervous to generalize it to the whole year. I don't think that's really as important as what we just did, okay? Now, because I have a little time here, like 5 minutes, I'm going to just say this. If you're having trouble doing the p-value, I'm sorry, the t-statistic, that step, we should just do it really quick. So if we had done the test statistic step for this question, the null hypothesis 50 would have been in the middle. And then the X bar that we had gotten was 48.9, which is on the left in this case. But remember, because this is a two-sided tail, we would have had to do a symmetrical sketch to the right as well. And then the t-score we would have gotten was negative 1.945, negative 1.945. That would have been your left t-score. So then your symmetrical right t-score would have been positive 1.945. If I wanted to do the test statistic formula, t equals, I would have done statistic, which is x bar, minus parameter, which is mu, and then sub-zero based on the null, divided by standard error of the statistic. So that is s divided by square root of n, okay? So I would have plugged in x bar, which was 48.9, minus mu, which was 50, assuming in the null, and then s was 1.929 over radical 12. And if I had done this out by hand, I should have gotten the negative value of the t-score, which was negative 1.945, okay? And then I would just do the symmetric one on the right-hand side, okay? So just reminding you, if I had gone to stat, gone over to tests, and I had gone to t-test, and I went to draw instead of calculate, it should sketch what I just said, which is a symmetric two-tailed p-value. Okay? All right. All right, my friends. Now, the second question I gave you on your sheet for today is actually a review about proportions, because I figured now that we're getting into means, do you remember proportions? So if you look at the next question about Amazon, this one, I brought it back to proportions, and I did this just to confuse you, but actually really because I wanted to see now if you had a proportion question, would you be able to switch gears back to proportions? Remember, it's going to be a z-score instead of a t-score. And remember, when you do your HO and your HA, your HO is going to be a p and not a mu, okay? So just remember that the things that change are the p and the p hat are the symbols instead of mu and x bar. This becomes a z-score instead of a t-score. And also when you do your assumptions, the first assumption stays the same, the second assumption stays the same, but the third one changes back to NP and NQ are greater than or equal to 10, okay? So remember, the beauty in doing this, if you get really good at this stuff, is you're going to get into the point where you realize that proportions and means is really just a matter of symbols. The z-score for proportions is p hat minus mu p hat over sigma p hat, which winds up being statistic minus parameter p over formula p 1 minus p over n. For means, it's x bar minus mu x bar over sigma x bar. Same pattern, but just now notice that it actually should be a t-score if you don't have sigma. So then it's going to be x bar minus the mean, mu, that you're assuming in the null, and this is a p sub 0 in the null, and then it's going to be s over radical n. So it's the same kind of pattern here. It's just you're using p hat for your statistic, and here you're using x bar for your statistic. Here you're using mu for your parameter, and here you're using p for your parameter, vice versa. And then here's your standard error of your p hat, And here's your standard error of your mean. Ran out of room, but anyway, you get the idea. All right, I hope to see you tomorrow. Bye.